Hey everyone, welcome to this video on Supervised Machine Learning. I'm Sharia and today I'm going to walk you through one of the most important areas in AI. So the things we're going to be going through is an overview of machine learning, like what is machine learning. We're also going to go over what is supervised learning versus unsupervised learning. We're going to go over the regression model. We're going to go over what gradient descent is. We're going to go over multiple linear regression, classification with logistic regression, and then cost function and gradient descent in logistic regression. And lastly, we'll do the problem with overfitting. So what exactly is machine learning? In simple terms, machine learning is when a computer learns from data. Instead of being told what to do step by step, it finds patterns and makes decisions on its own. Think about how Netflix recommends shows. It learns what you like based on what you've watched before. That's machine learning in action. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforced learning. In supervised learning, you give the machine examples with the correct answer. It's like giving a student a workbook with the answer keys to learn from. Unsupervised learning is when you give data without answers and it figures out the patterns on its own. And reinforcement learning is like sort of training a dog. You reward the machine for good behavior, and over time it learns to repeat those actions. But in this video, we're going to mostly focus on supervised learning. So supervised learning versus unsupervised learning. In supervised learning, you have labeled data. That means each input has a correct output aligned with it. For example, predicting whether email is spam, you train a model with examples of emails labeled spam or not spam, so it learns what spam looks like. In unsupervised learning, there are no labels, so the model just looks for patterns and similarities in the data. An example could be, imagine you run a store and have thousands of customer records. An unsupervised learning algorithm could group similar customers together even if you don't know why they're similar. This is helpful for marketing and recommendation systems. And a good way to think about it is supervised learning is learning from examples with answers, and unsupervised learning is discovering similarities and patterns in raw data. So here's a linear regression model. So this is one of the most simple models in supervised learning, the linear regression model. This is used when we want to predict a continuous value, like a price, height, or a temperature. Let's say you want to predict someone's weight based on their height. You collect data on a bunch of people and then draw the best fitting straight line through those points. That's a linear regression line. And the equation is y hat, which just means the predicted y, plus a weight times x plus b. And so x are the features like the height, age, and everything else. And then the weight is the way the model makes the line. And then b is the bias or intercept. The goal is to find values of w and b that best fit the data to make the linear regression model. So now we'll move on to gradient descent. Now let's talk about one of the most important ideas in all of machine learning, gradient descent. So to understand how this works, imagine you're somewhere on a mountain, blindfolded, and your goal is to find your way to the very bottom of the mountain, the lowest point possible. You can't see where the bottom is, but you can feel what direction the ground slopes downward beneath your feet. So you take a small step in that direction, and then take another and another, and eventually you'll be downhill at the bottom. So you can think of this big graph here that you're standing on top of the mountain, and what gradient descent will do, it will try and find the fastest route down, all the way down. And that's exactly how gradient descent works. But instead of a mountain, you're trying to minimize a cost function, which is also known as the loss. And instead of walking, you're updating the model's parameters. So the actual formula that powers this process is the update rule, which is over here. So theta is the model parameter, and it represents the weights and bias. Alpha is the learning rate, and it controls how big of a step we take on the mountain, okay? And then j of theta is the slope of the gradient descent, which tells us which direction and how fast the cost function will go down. So with each step that gradient descent takes, it looks at how bad the model's predictions are and adjusts it so the cost function as low as possible. Over many steps, the model gets better at making predictions and the cost function keeps going down. So then you get the perfect model parameters. Now let's move on to multiple linear regression and vectorization. So often one feature isn't enough, and that's where multiple linear regression comes in. Instead of having a feature as just height, maybe we want to include age, gender, or activity level to predict someone's weight. This is still linear regression, but just with more features. And now that we have more data, computations become very big. So that's why we use vectorization. Vectorization can help make your operations go way faster and more efficient. Now let's move on to classification with logistic regression. Despite the name, logistic regression actually is used for classification, not regression. It answers yes or no questions like, is this email spam? Is this patient sick? Will the customer buy the product? These are all yes or no questions. So instead of predicting a number like the regression line does, it predicts a probability between 0 and 1 using the sigmoid function, as you can see as y hat equals 1 over 1 plus e to the negative wtx plus b. If y hat is above 0.5, we can predict class 1, and if below 0.5, we can predict class 0. So class 1 is just yes, and then class 0 is just no. So classification with logistic regression is basically just like flipping a coin, but it's based on data. Now we can move on to cost function, gradient descent, and logistic regression. Just like linear regression, we train logistic regression with gradient descent, but using a different cost function. We use something called log loss or cross entropy loss, which is shown in the equation. Why not you just use regular error? Because probabilities behave differently. Log loss penalizes incorrect confident predictions more harshly, which is exactly what we want. Gradient descent minimizes this cost step by step to make our predictions a lot better. Now we can move on to the problem with overfitting. The problem of overfitting. Overfitting is a common trap in machine learning. This happens when your model learns the training data too well. So it learns based off all the noise and random quirks in the data. It performs really great on the training data, but really bad on new data because it's so fit to the training data. Imagine a student who memorizes every question on last year's test, but doesn't understand the subject. They'll fail this year's test because they memorized last year's test perfectly, but they didn't understand the concept of the test. So that's what you call overfitting, but in machine learning. So some causes of overfitting is having your model being way too complex. So the line fits to the data absolutely perfectly, or having not enough data, or training it for way too long so it perfectly fits it. That's going to cause overfitting. To fix overfitting, use simpler models that don't fit the data that perfect so that it will work on new data better. And by adding regularization, which is adding a penalty to the cost function that discourages the model from becoming way too complex. And you can also get more data and use cross-validation to check your performance with the new data. So that just wraps up our dive into supervised machine learning. We covered everything from basic concepts and real challenges like overfitting. We looked at linear and logistic regression and how gradient descent works and how to keep your models from going off the rails. Thank you for watching this video on supervised machine learning.